Let's use the law of sines to solve a triangle. We want to solve triangle ABC if A is 32 degrees, B is 81.8 degrees, and side A is 42.9 centimeters. Well, let me start by sketching a triangle and labeling the information I'm given. So we have a triangle that could possibly look like this. I'll call this angle A, angle B, angle C. Let's see, angle A is 32 degrees. Angle B is 81.8. Side A is always opposite angle A. It's 42.9 centimeters. And those are the things I know. The things I'm missing are angle C, side C, and side B. We can find any one of those at any point. Let's start by finding side B. Using the law of sines, I can say or use that A over sine angle A is equal to B over sine angle B. And I'll fill in what I know. Side A is 42.9. Angle A is 32. Side B, I don't know. Angle B is 81.8 degrees. These are in degrees. Continuing with that, to isolate B, all I need to do is multiply by sine of 81.8. And I'll be looking for 42.9 times the sine of 81.8 degrees divided by the sine of 32 degrees, and that's equal to side B. With the help of a calculator, I would calculate this number. Make sure your calculator's in degree mode. If your calculator's in degree mode and you round to one decimal place, you'll see that side B is about 80.1, and the units on our sides are centimeters. So I found side B. The next item I want to find for my triangle is angle C. Note that angle C plus angle A plus angle B have to sum to 180. So to find angle C, I can take 180 minus 32 minus 81.8. So to find angle C, I can take 180 degrees, subtract 32 degrees, and subtract 81.8 degrees. And again, with the help of a calculator, you could find that angle C is about 66.2 degrees. Now, if you look back at our triangle, we're missing one more side. We're missing side C. Let's go back to the law of sines and use side A over sine angle A is side C over sine angle C, and we'll solve for side C. Filling in information I know, side A is 42.9, angle A is 32 degrees, side C I'm looking for, angle C is 66.2 degrees. To isolate side C, I can multiply by sine of 66.2, which means I need to find 42.9 sine 66.2 degrees divided by sine 32 degrees, and that will be side C. Again, with the help of a calculator, in degree mode and rounding to one decimal place, you'll find that side C is approximately 74.1 centimeters. Let's solve an application problem using law of sines. Jerry Keefe wishes to measure the distance across the Big Muddy River. He determines that C is 112.9 degrees, A is 31.1 degrees, and B is 347.6 feet. So over here, A is 31.10 degrees, C is 112.90 degrees, and B is 347.6 feet. So we have that information. We want to find the distance A, which is labeled here, across the river. Well, in order to find the distance A and to use the law of sines, I have side B. I'm going to need angle B. Remember that the three angles in a triangle have to add up to 180. To get angle B, I can take 180 degrees, subtract 31.10 degrees, and subtract 112.90 degrees to find angle B. You can find that with the help of a calculator, and you'll see that it comes out to 36 degrees. Well, that's not side A, but it is angle B, and now I can apply the law of sines to find side A. The law of sines says that side A over the sine of angle A is equal to side B over the sine of angle B. Well, I'm looking for side A, but I know angle A is 112, no, actually angle A is 31.10 degrees. Side B I know is 347.6 feet, and angle B is 36 degrees. We just solved for that. I'm looking for side A. So at this point, I can multiply each side of the equation by the sine of 31.1, which will isolate side A, and I'll need to find 347.6 times the sine of 31.10 divided by the sine of 36.00 degrees. Now, with the help of a calculator, make sure that it's in degree mode if you're going to use or make this particular calculation. You can do this calculation. You'll find that A comes out to approximately 305.5, and our answer is in feet. Let's solve an application problem. Two ranger stations are on an east-west line 110 miles apart. A forest fire is located on a bearing of north 42 degrees east from the western station at A, and a bearing of north 15 degrees east from the eastern station at B. How far is the fire from the western station? Well, it's a good idea to draw a picture for this problem, and I've done most of that. Here's station A. Notice that it is west of station B. The fire is here at the location that I've called C. C, or the fire, is north 15 degrees east of station B, and north, this is a north line, 42 degrees east of station A. Station A and B are 110 miles apart, and the question is for us to find what I would call side B in the triangle, in words, how far the fire is from station A. Well, in order to apply the law of sines to solve, we're going to need some of the angles in the triangle. Let's start with angle B. This part of angle B is 15 degrees. To get all of angle B, I'm going to add 15 degrees to 90 degrees, because the rest of angle B is a 90-degree angle. Angle B is 105 degrees. I also need angle A. To get angle A in my triangle, realize that this north line with this east line, east-west line, forms a 90-degree angle. Part of that is 42, but angle A can be found by taking 90 degrees and subtracting 42 degrees. If you take 90 minus 42, you end up with 48 degrees for angle A. So, let's see what we have. We're looking for side B. I have angle B. Side B, I have angle A, but this side is side C. So I'm going to need the angle where I've located the fire at angle C. To get angle C, I can take 180 degrees, the sum of the three angles in the triangle, subtract 105, and subtract 48 degrees. If you make that subtraction, you'll find that angle C is 27 degrees. And now I'm ready to put together a law of sines statement that'll allow me to find B. I'll write down law of sines. B over sine angle B is C over sine angle C. And then I'll fill in the information that I know. But I'm going to move to another piece of paper. So what I want to do is put together B over sine angle B equals C over sine angle C. Now the thing I'm looking for is B. I know that angle B is 105 degrees. Side C is 110. Angle C I just found to be 27 degrees. To solve for B, I can multiply each side by sine 105 B is going to come out to 110 sine 105 degrees divided by sine 27 degrees. And with the help of a calculator in degree mode, I can see that B is about, not exactly, 234, and my units in this problem are in miles. Let's find the area of a triangle. We want to find the area of triangle ABC. The information that we know is side A is 34 feet, side C is 42 feet, angle B is 55 degrees 10 minutes. Well, there's an area of triangle formula that says I can find the area of the triangle if I know side A, side C, and angle B. Let me fill in the values for each of these variables. Side A is 34, side C is 42, angle B is 55 degrees 10 minutes. And all I need to do is crunch a number on my calculator. Well, let's go ahead and grab our calculator and put that set of values in. So what we want to do at home screen is put in 1/2. We want to put in that times 34 times 42, whoops, not 429, 42 times the sine of 55 degrees 10 minutes. So put in 55, choose angle on your calculator and enter on the degree symbol. Then put in 10, go back to angle, go down to option 2 and enter. And that's 55 degrees 10 minutes. So I have 1/2 times 34 times 42 times the sine of 55 degrees 10 minutes. I should make sure my mode is degree mode, and it is. So I can push enter, and I see 586. The area of the triangle is 586 square feet.
Find the area of the triangle ABC. We're given certain pieces of information. Angle A is 24 degrees 40 minutes. Angle C is 52 degrees 40 minutes. And side B is 27.3 centimeters. Before we can use the area formula, we must find either side A or side C. I'm going to decide to find side A, but to do that, we want to use the law of sines. In order to use the law of sines, we need to have the angle opposite this length B, which means angle B. And what we know is that for any triangle, A plus B plus C must equal 180 degrees. That is, the sum of the angles is 180. So that means that angle B would be equal to 180 degrees minus angles A and C. That is, B equals 180 degrees minus angle A, 24 degrees 40 minutes, minus angle C, which is 52 degrees 40 minutes. And simplifying, we find that angle B is equal to 102 degrees 40 minutes. So 102 degrees 40 minutes. Now we can use the law of sines because we have an angle and the side opposite it. We know the angle here, and we want to find the side opposite it. So let's first look at the general formula for the law of sines and then substitute the values that we know. So A divided by the sine of angle A equals B divided by the sine of angle B is the law of sines. We're attempting to find A, and so now we substitute in the angle A, the angle B, and side B. So we have A divided by the sine of angle A, which would be the sine of 24 degrees 40 minutes. Side B, recall, is 27.3 divided by the sine of angle B, so the sine of 102 degrees 40 minutes. We multiply both sides by the sine of 24 degrees 40 minutes, and that will give us that A is equal to 27.3 times the sine of 24 degrees 40 minutes divided by the sine of 102 degrees 40 minutes. We evaluate that using a calculator. We'll find that A is approximately equal to 11.7 centimeters. Well, now that we know the two sides A and B and their included angle C, we can use the area formula that says the area of a triangle is 1/2 A times B times the sine of angle C. And that's going to equal 1/2. A is 11.7. B is 27.3. And then the sine of 52 degrees 40 minutes. We evaluate that on a calculator and we'll find that the area is approximately equal to 127 square centimeters.